So let me start. Climate change and global warming step towards a green earth. Part 3 presentation. There we will present today for the part of waste management. So from here we'll start today waste management. So first is that the generation of waste. So the amount and composition of waste can vary depending on the factors such as population growth, urbanization, and the economic activity. So, what is the task for us that we are trying to control the waste by 2050? And we are trying to consider this all calculations like a waste generation is 70%. That this is the situation is that average waste generation per capita is 1.1 to 4.5 kilograms per day for high income countries. Whereas the low income country, the average waste generation per capita is less than 1 kilogram per day. So this is the situation. So by 2050, it will increase the waste generation 70% if we cannot stop it. How it will increase? Because of the population growth, urbanization, and also the economic growth. So this waste is not only this specific type of solid waste or liquid waste or nuclear waste or e-waste, anything. It's a combination of all these things. So the main task for us is to reduce the waste anyhow, or if possible, we should consider for the nullification of the waste, zero waste, if possible. So first, let me explain regarding the different types of generations of waste, that what are the generations of waste are there. First, the plastic waste we are considering, that is so sensitive. The plastic waste has gained more attention lately than the other waste due to its effect on marine life. Number one. Number two, e-waste generation is higher in developed and wealthier nations. Less than 20% of waste is recycled. That is why waste management models are being transformed into a circular model and also known as a circular economy rather than a linear model. So finally, circular economy gains popularity because of a finite resource of waste management, because raw material is fixed. So then, the food waste and e-waste and municipal solid waste are labeled as non-hazardous waste, and nuclear waste is labeled as the hazardous waste. So that's why we can write this way, that waste we are separating in two parts. One is the hazardous and a non-hazardous. And this hazardous waste detrimental to human health, and non-hazardous less harmful in the living being. So we how do we reduce the waste? That these are the waste pattern and how to do these things we can explain one by one. So waste reduction, we are considering food waste, e-waste, municipal solid waste, nuclear waste. And then within e-waste, we are considering mobile waste, computer waste, TV and other wastes. So now we are considering for the food waste. That food waste is categorized as the biodegradable waste. According to UN, approximately one third of the food, 1.3 billion metric tons per year, is wasted. So when food waste decomposes in landfill, it produces methane, huge amount of methane. It's not small amount. This is the picture we took from the internet. So you can check it that how much amount of the food wastes are going on. Let's go for the e-waste. So for e-waste refers to the discarded electrical or electronic devices, including computers, smartphones, and other electronic appliances. According to the Global E-Waste Monitor 2020 report, approximately 53.6 million metric tons of e-waste were generated globally. So this is the situation of the e-waste. Based on the e-waste, we have published a paper in 2020 in IJPE, International Journal of Production Economics, and that paper is also one of the best cited papers for me, along with uh, for the Yonsei University's newsletter. That paper was selected, and Yonsei University published that one for newsletter as a newsletter publication. So one of the best area of research is the e-waste. Next, the matter of the municipal solid waste. This includes everyday household waste such as food scraps, packaging, paper, plastics, and other materials that are discarded by the households. One of the significant climate impacts of this municipal solid waste is the generation of methane gas during the decomposition of organic waste in landfills. So, what is this main concern of the municipal solid waste? That is the amount is huge, and we really do not know how to control all these things. But we are trying to cover by different decomposition approaches, reduction of MSW with different types of policies or strategies. Next, the nuclear waste. So this is the most sensitive one because nuclear waste is the radioactive materials that are generated by the byproducts of nuclear power generation and nuclear weapon production. These nuclear wastes, are categorized in three ways based on the radioactivity. So 3% high level waste, spent fuel, 7% intermediate level waste, effluent components, steel extracts, etc. 90% low level waste, tool, stools, clothes, and etc. Others. So these are the all generation of wastes. So the next part is the matter of mm, research contributions and others. So that is the most important part of this area of research. Whatever we have done, and then what are the possible options we can do in future also. Let's continue with this one. So first is the research contribution to climate change, food waste reduction policies. So what we have done, as I said that with my graduate students, now he became a faculty. But in 2023, we have published another paper in Journal of Cleaner Production with him that that the concept is the nullifying waste within the circular economy. Now, concern is that what is this nullifying waste? What does it mean, nullify? Nullify is nothing but the what zero. That means we must reach zero waste. There is no matter that we are reducing waste. So mathematically, we prove that we can nullify the waste. So it means whatever be the policy we are using that it is confirmed that the product, that means the waste from that supply chain we are considering from the supply chain can be uh, considered that the zero waste total. Like I'm just giving an example. Then what type of things we have done? We consider the data and the model from a concept of the bakery, that the bread, cake they are preparing. What the main concept concern is there, that whatever the fresh foods that they are selling, and if it is mm, not in the status to sell again, so they are mm, totally destroying. Now, do you think so? Destroying means that they just throw it out for no purpose. It's not like that. So those foods are used like a sandwich. Okay, it deteriorated. Say a cake is deteriorated. So human cannot eat that one. But if I consider the secondary supply chain to produce or transfer that food into a food of animal like fish, hen, or birds, they can take the food. That means they can consume this food. So then there will be no, that means no waste from the whole chain combination with the supply chain 1 and supply chain 2. That means if we consider two supply chain together, primary supply chain will consider for the food production and the selling and all these things. Whatever the leftover from the primary chain, it will move to secondary chain. And then whenever the secondary chain is there, then in the secondary chain, the whole food is consumed. So if it is consumed, then there is no waste. That's why we are calling nullifying waste. And that is the concept of the circular economy. That means from waste to resource, first we are going with the production, then consumption, then waste management, and from waste we are going for the resources again. So this is the concept of the circular economy that we have done within this study. So that I said already, that these are the bread bakery waste. So that from we are taking from the first stage, and this is the second stage, and then when the manufacturer from the retailer it is sold, that whatever the uh, low price, using third party consumer low price they are selling, but it is still not sold, that 3PL collects there as waste. This 3PL is nothing but the third party logistics, and then it will be recycled here, and after recycle that can be make the animal feed. Okay, the total consumption is there. So as a result, these things are considered as the nullification of waste that we proved mathematically through the supply chain model, and we published. And one of the best cited papers also this one in this field, the circular economy. So that was the first paper that I just said already, that Professor Antony is there, from whom I learned um, that whole concept of the circular economy in that conference in Taiwan in 2019. And then I started with the task with the graduate student in 2020, and finally published the paper in 2022. And I said already that the concept of nullifying waste. So no waste is left in the CLSC. CLSC means the closed loop supply chain. So specifically, three are reduction, restoration, and recycling, that convert it into a circular economy model. And that is also published in the Journal of Cleaner Production, one of the top rated journal, the Q1 journal is that. And this is the consideration, sorry, this is the consideration is there. As I already mentioned, the two-stage supply chain is there. First stage, second stage. From the first stage, primary supply chain, the forward supply chain, and move to the multi-echelon. And then secondary supply chain, second stage, secondary supply chain from backward, same we are considering. There also we are considering the multi-echelon. And there's the waste circulation. These way the things are considering. So that paper published in Shorkar, sorry, ETL 2022, that paper published in the circular economy. The next paper we published in the RARO, that consideration with the optimization of the energy cycle under a sustainable supply chain management. So here we are considering also the food waste management can be used as a raw material for producing the renewable energy. So food waste we are considering for the energy matter. So like biofuel supply chain moves forward to the second, third, and fourth generation biofuel. Similarly, we are considering the food waste. And this food waste we are using for the renewable energy matter. So here the food waste supply chain, that the non-waste and the food waste is there. That means whatever the things are, if this is not waste, so we are going for preservation. This is food supply chain. And if the food waste, then the plant animal, then reuse, recycle, recovery, disposal, and there's incineration. So through disposal, landfills are there. Through recovery, the different types of biofertilizer, power, heat, and from reuse also, that the biofuels, enzymes, and other things are there. So there is the environmental risk. This side is too high, this side is too low. So this way the food supply chain is going on. Next, another two studies research paper we published in the one of them in the Journal of Cleaner Production in 2020, and this is 2023 in fuel. One paper with Mitali Sharkar, professor, she's professor now, and another paper with he became graduated already from India under my supervision, and he is the professor from IIT Delhi, civil engineering, because I need a huge help from him. So he helped a lot. And because of him, I often visit IIT Delhi several times. And she's the professor of his supervisor, and I'm the co-supervisor. So under our joint supervision, that student graduated already. So that paper published in Fuel. So two papers are there. Second generation biofuel are produced from this biofuel, cellulosic biofuel, and the stakes of wheat, corn, and woods of any unused skin. And third generation biofuel is produced from algae. Fourth generation biofuel is produced from the genetically engineered feedstock. So this is the basically ongoing research are going on. And here what we have done, that how does an industry reduce waste and consumed energy within a multi-stage smart sustainable biofuel production system. And the second paper, what we have done, then an efficient, sustainable, smart approach we are considering to biofuel production, with emphasizing the environmental and energy aspects. Next, another study we have published in 2023 with one of my students. That student also graduated last year, and he will join this year in Yonsei University under my supervision as a postdoc. So he's coming here in Korea. So animal fat wastes are converted into biodiesel or others, and government subsidies are beneficial for waste to energy production centers. That specifically things are there, that this is the government subsidy, and these are type of advertisements are there. That paper is also published in the Journal of Cleaner Production. As I said already, the Q1 paper, Q1 journal. And there we are considering the waste animal fat, something new thing we are considering. That what is this waste animal fat? That um, like pork, beef, whenever this meat are produced, so huge amount of fat are there, animal fat. So those are the generally waste. So what is my research invention, that uh, without going to waste this type of thing, what we can do, we can prepare them as a fuel, and that can be substitute as like a petrol, diesel, or something. So these are the research contributed by this one, and this is the concept that it can save, the environmental impacts is huge. Okay, so that is the chain we consider supply chain. Next, for the e-waste reduction, that uh, as I said, that smart reallocation matter. Yale University, um, in newsletter they publish this one. The tracking and remanufacturing of e-waste management can be carried out through the resource recovery of end-of-life products and reverse logistics. So these UL products pass through testing, sorting, and disassembling. Those wastes are then sent to the repair and recycling. So this concept we published in the IGP, but Yonsei University published this one for the newsletter and for the research, and it's highlighted so much. And the main concern is the e-waste for the RFID tracking, because using the RFID antenna, there are two type of passive and active antenna are there. So that the passive scanners are there. So that within the scanner, with the scanner, they are scanning the uh, RFID tag is there or not. So this type of things are using the GPS systems also are using during the transportation. Then transportation and manufacturing, both cases, means the production cases, that it is automatically detected that where is the product because of the RFID tag. This type of thing. So if we use the RFID, can be used in increased return rate and recycling. Next, that is the paper we published in 2020, that use electronic devices used can tracked easily by the RFID tracking. So we put that one, that recovery channel selection in a hybrid manufacturing remanufacturing production model with RFID and product quality. So this paper we published there, RFID, in IGP, International Journal of Production Economics. And then municipal waste, there here considering about 80% of municipal solid waste is used for raw material for reuse or for remanufacturing, and the rest 20% municipal use for the renewable energy. And this we are going for, sorry, this is the in our waste, e-waste, general waste, recyclable waste, and this is the biodegradable waste. And that paper we have published, waste to energy, again another extension of the earlier paper. So reduction of waste and carbon emission through the selection of item and cross price elasticity demand to form a sustainable supply chain with the preservation technology. So that we have done here also, that incineration, gasification, pyrolysis, and through incineration, waste can be converted to heat, to gas and ashes. Of course, non-harmful product. So two papers, as we wrote already, that Xing ETAL 2023, just said with my graduate student, and this is with my collaborators. These are not my students, so these are the collaborators from India. So Jadhav BTL, this is he is professor. So with Professor Jadhav, that we published the paper. Next, the nuclear waste reduction, that the Philippines renews its call for cooperation with Korea regarding its push to resume the long settled project to build the nuclear power plant. So Philippines has been mm, pushing the strain to the nuclear power plant generation to deal with the climate change in the and the energy crisis. So Korean cooperation is also needed to conduct a necessary test to resume the construction according to the ministry, because we have the option to apply for the project where the waste reduction, nuclear waste reduction is going on there, and that research is going on this area so much. And finally, the development with the environment with as much as discussions, so that video will be uploaded today or tomorrow. So you will check it, that if you need to discuss anything, you can contact to me directly. And these are the reference. So this is the email ID. You can talk to me directly, or you can directly visit to my office in Yonsei University in Department of Industrial Engineering, ninth floor is my office. So you can come. Thank you very much. Hope it will helpful for you.